Good morning. We present the work entitled A Fractal and Wavelet-based Approach for Audio Coding. To design a low-cost algorithm for searching the minimum bit rate wavelet pack representation to encode high-quality general audio in a perceptual or rate distortion sense by using a particular family of wavelets, wavelet-specific family of wavelets, finding adaptively the corresponding filter's length according to the proposed cost function and the input audio file being encoded. Make it possible to decode and codify the string in real time. Bit allocation, strategy of bit allocation is based on the best-based approach, where the entropy E can be momentary entropy, M, perceptual entropy, P. M used when a rate distortion criterion is being considered. P used when the perceptual criterion is being considered. Okay? Three requirements. Requirement 1. Related with the length of the filters N that is responsible for time resolution R and frequency selectivity key. As N increases, key increases and R decreases, and vice versa. Okay? Requirement 2. Almost linear phase responses of H and G are required to avoid distortion. Requirement 3. The shape and number of the vanishing moments of the scaling and wavelet functions should be carefully chosen. Okay. Requirement 1. Adaptive choice of N between 12 and 48 to obtain the best compression according to the audio frame being encoded. Requirement 2. FI filters are required. Symmetrical or unsymmetrical filters are required, but higher wavelets cannot be used because they fail to satisfy requirement 1 and equals 2. Therefore, the most appropriate are simulants. Okay. Requirement 3. Automatically carried out by requirement 2.
According to the requirements above, we conclude Wavelet is the best wavelet to be used for audio compression. We obtain HFIR, low pass. We obtain H filter synthesis, high pass, alternate flippy, order flippy, alternate size. Traditional perception criterion. The traditional perception criterion to be expressed in the Fourier or wavelet domain. Proposed perception criterion. We proposed the wavelet-based perception entropy using simulax wavelets with the adaptive choice of the length of the filters according to this input-out frame. Traditional rate distortion criteria. The traditional rate distortion criteria is the entropy associated with the Lagrangian cost function. Proposed rate distortion criteria. The proposed rate distortion criteria is the use of fractal dimension as measure of distortion plus the use of singlets and the adaptive choice of the length of the filters according to input-out frame. This is proposed algorithm, step 1, 2, and 3, input signal and output signal code. Tests. At a bit rate of about 60 kilobits per second, the encoded files are perceptibly transparent and the original and the decoded clips are not distinguishable. 20 volunteers participated in the initial tests, aged from 20 to 50. No one could distinguish between the original and the decoded files. The conclusions. Singlet showed to be excellent choice for perceptual transparent audio coding, and the adaptive choice of M did not cause problematic delays in practice. Fractal dimension can be used as the alternative choice to measure distortion and encode the audio in a rate distortion sense. The algorithm has a low order of computational complexity in relation to these input signals length and can be used in real time. Thank you very much.
Any questions?
I've got one. With respect to,
Go ahead.
with respect to your listening tests, what type of environment are you using for tests? I mean, are people using closed ear headsets or local speakers?
I have a participation in this world. They use the closed headphones.
Okay.
Just out of interest, what were the ages of the people that were tested? Because I mean, as you get older, your sensitivity drops. So if you tested people that were sort of young, you might get different results than the people. Sorry, you said age 20 to 50. Did you test? Was there any test done with someone younger than 20?
Okay, we did not test for younger volunteers, or we intended to do so. Okay, at that time we did not find a younger volunteer to test. We think that this age is more confident. It's more confident, but we will try to improve this by experiment the same procedure with young researchers. Okay. We'll try to do so later, but these results are based on this age as well.
Can you also tell us a little bit about the actual clips themselves and what type of...
It spans rock, pop music, jazz, and lots of music. Okay, but in general, audio, not speech. Music.
Can you just elaborate a little bit more on your choice of using simlets rather than something like Dobashi's wavelets or something like that, like a different wavelet-based? Well, I know you said it matched two of the criterions best, but could you just elaborate on how it matched those criteria?
Yes, we proposed these three criteria. Let me return it here. First of all, if you have a big filter, okay, a filter with a lot of coefficients, you have a good frequency response. And surely this is desirable. Okay? Well, on the other hand, if you have a filter with a lot of coefficients, you will lose time resolution. So we have to balance the values. We are going to find the length of the filters adaptively, according to the input signal. But we want to fix the family of wavelets we are going to use. We are going to say we are going to use this family of wavelets. Okay? Why? Because if you try to experiment to all the families of wavelets with all the support sizes, it will be a very you have a very big cost to do so. So we try to decide, no, we are going to use this family of wavelets, and only the taps and only the number of coefficients will be found adaptive. Okay? This requirement we define it, but it's surely desirable. The second one is also desirable, because if you do not have a linear phase filter, what is going to happen? We will have distortion, okay? Because we need linear phase to avoid distortion in the filter and signal, the decomposing signal. The third one is related to the decoding process. You have to use smooth functions, because if you do not use smooth functions, your decoded file, your decoded audio clip may suffer of spikes when you recombine the signal. So we defined these three requirements and started our experiment with these three requirements. We are not saying here that this is all, that this is enough. We are trying these three requirements and got a good result based only on these requirements. Okay? But it's possible to improve this, sure. Okay? What else? Thank you, Dr. Vieira. Now the third talk.